Take a look at the conventional circuit for GCSE Physics. So we know that electrons, they move from negative to the positive terminal. But the conventional circuit, within the conventional circuits, basically the electrons move from the positive terminal to the negative terminal. Then this is called the conventional circuit. So the movement of electrons, right? It's what powers our electrical devices, like our bulbs, our phones, everything. It's powered by the movement of electrons. So if we have our battery here, and we have our light bulb here, the movement of these electrons around the circuit is what actually powers our light bulb. It's not this electron getting used up and leaving nothing. It doesn't disappear. It's not used up. It just goes around. That's how it powers it. The movement of these electrons around the circuit is what powers it. So electrons don't get used up. They simply flow from the negative to the positive terminal. However, of the conventional circuit. But let me just explain this first. Why do our batteries die then? If our electrons are just simply moving around our circuit, why do they die? Why do batteries die? Why do they run out of electrons? Well, essentially, the really simple definition is that once these electrons get pushed out of one side, so we often draw it as the longer side of our diagram having the positive, and the shorter side is the negative terminal. So here I drew the conventional circuit. Essentially, once electrons get pushed out of one side and they reach the other side of the circuit, they need to be brought back. So once these electrons finish here, right, they need to be put back to their positive side in order to start their movement again. To move from one side to the other terminal again, they need to be brought back to their original starting terminals. And this is why we charge our batteries. When we charge our batteries, we're essentially we're reversing the movement of electrons back to where it started, so that we can restart this movement again and power our electrical devices. That's what charging is, bringing the electrons back to their starting terminal so they can move about again. So the movement of electrons back to the opposite terminal can power our electrical devices. But remember how batteries are rechargeable? Rechargeable batteries, they can degrade. By the way, single-use batteries, the reason that they supposedly die is because you can't recharge them and move the electrons back. That's why they die. But you know how rechargeable batteries, they degrade? It's essentially when you have your phone, but after like 2 years of using it, your battery life, you'll find out that it's actually shorter than what it used to be when you first got the phone. And that's because your battery is degrading. Okay, so batteries like AA, they can't recharge or move the electrons back, so they die, right? But rechargeable, they can reverse the electrons. But in doing so, in bringing these electrons back to their original starting point, some of the electrons, they disappear. They get lost. It's not 100% efficient, right? Nothing can be 100% efficient. So some of the electrons, they disappear. So it loses their overall efficiency, and that's why your batteries can degrade over time. So, back to our conventional circuit. Electrons do move from negative to positive, and we call this type of current the electron current, because this is what it theoretically should be. But we have something called the conventional current, and nowadays we don't even call it the conventional current. It is just the current, because this has just become our default. The conventional current is our default, despite not being the initial way, the actual way the electrons move. So the current was discovered. The reason why we have this confusing system is because the current system, they discovered the current first. And when they first discovered it, they thought current moved from the positive to the negative terminal. They thought electrons moved from the positive to negative terminal. That's why the conventional current that we currently use goes from positive to negative, because the current was actually discovered before electrons. And at the time when they discovered it, they thought it flowed from positive to negative, but now we know it flows from negative to positive. But before, when they first discovered it, they thought this was how it actually works. And the truth was discovered like almost 100 years later. 100 years is a long time. It's like an entire lifetime. And therefore, we just use the conventional current. Because we don't want to, like, within 100 years is a long time, right? There's going to be hundreds of theories being written, hundreds of books, hundreds of new devices being created using this theory. So just switching everything back would have taken a lot of time, work, and probably money too. So we just use the conventional current of positive to negative. We just use it. We're too lazy to switch it back. And for your GCSEs, just know that current flows from positive to the negative terminal. And in the next video, we'll take a look at the most important equation in the entirety of the physics electricity unit, the V equals IR equation. Thanks for watching this one.